Number 8, find the equation of the tangent line to the curve 2x cubed minus 30y squared equals 8 at the point 4, 2. So if we want an equation of the tangent line, we will have a y equals mx plus b. So here we go. Alrighty, on this one, we want to go ahead and take the derivative to find the slope. I do notice that this is implicit differentiation. So if I take the derivative with respect to y, I do have to put dy dx with it. So the derivative of 2x cubed is 6x squared minus the derivative of 30y squared will be 60y dy dx, and then equals the derivative of 8 is 0. Okay, now we're going to solve for dy dx, so I'm going to subtract 6x squared from both sides. Okay, and now to get dy dx by itself, I'm going to divide both sides by negative 60y. And so I'll have dy dx is equal to negative 6 over 60 will reduce to 1/10, so this will be x squared over 10y. And now from here, I just need to plug in the point 4, 2. So plug in 4 for my x and 2 for my y. So here we go. We're going to have dy dx equals x will be 4 squared over 10 times 2 will be 20. So we'll get 16 over 20, which reduces to 4/5. And so that was dy dx. And we are not done because all we have found so far is just the slope. So now there are a couple different ways that we could do this. If you just want to use the point slope formula, we could, which would be y minus 2 equals the slope times x minus 4. So that would be one way, but we could also go ahead and find b. So my other one would be to use y equals mx plus b. My y is 2, my m is 4/5, my x is 4 plus b. So I'd get 2 equals 16/5 plus b. I'm going to subtract 16/5 from both sides. And so let's see, that will be 10/5 minus 16/5, which will give me negative 6/5 for my b. So my equation will be y equals 4/5 x minus 6/5. And both of those answers would be totally fine. Okay, number 9. If the graph of f of x equals x squared minus kx plus 7 has a relative minimum at x equals 3, then the value of k is what? Well, in order to have a relative minimum, we know that f prime will have to change from negative to positive. In order to figure that out, we're going to have to find f prime. We're going to have to find a critical value and then make sure that it changes, f prime changes from negative to positive. So let's find f prime first. The derivative of x squared is 2x minus the derivative of kx would be k. And so that's all I have so far here. We do know that it's happening at 3, so I could go ahead and plug 3 in for my x. So if I do that, I'm going to get 6 minus k. I want to set that equal to 0, and that's going to happen. So that means that k would equal 6. So let's just double check if I put that in there. Let's make sure that it does have a relative minimum at x equals 3. So if I have f of x is equal to x squared minus 6x plus 7, the derivative would be 2x minus 6. If I set that equal to 0, yes, it does have a critical value at x equals 3. So if I made an f prime chart, plugged in 3, if I plugged in like 0 into the derivative, I'm going to get a negative number. If I plugged 4 into the derivative, I'm going to get a positive number. So there is a relative minimum at x equals 3. So k is equal to 6. Okay, number 10, if y equals 5x times the quantity 2x plus 7 to the third, then dy dx is equal to what? I notice on this one that it is a product, so we're going to use the product rule. So f and g, f prime will equal 5x. To find g prime, we are going to do a u substitution, so my u would equal 2x plus 7, and my du would equal 2. So getting g prime, the derivative of u cubed would be 3u squared times du. That will equal 3 times u squared, which would be 2x plus 7 squared, times du, which is 2. And then if I clean that up a little bit more, that would be 6 times the quantity 2x plus 7 squared. Okay, now I'm ready to take the derivative. So y prime equals f prime times g, so it'll be 5x times 2x plus 7 to the third, plus f times g prime, so 5x times 6 times the quantity 2x plus 7 squared. Now, I'm guessing we could keep it like that, but I noticed that This one actually doesn't have an x on it, just has a 5. Oh, this is just 5, sorry about that. Okay, so this one, if I noticed I could factor out a 5, and I could factor out a 2x plus 7 to the second, so that's exactly what I'm going to do. And when I do that, I will end up, if I factor out the 5 and 2 of the 2x plus 7s, I will be left with one of the 2x plus 7s, and then plus, if I factor out the 5, I'll be left with 6x, and then that is it. And now I can just combine like terms. So I'm going to have 5 times 2x plus 7 squared times 8x plus 7, and then that will be my derivative. Okay, number 11, draw a slope field for the differential equation. dy dx is equal to x plus 2. We know that dy dx is just the slope, so I'm just going to draw little slopes. And I think the easiest way to do that is figure out where the slope is going to equal 0. So when x equals negative 2, the slope will equal 0. So everywhere x equals negative 2, we're going to have a slope of 0. Okay, and I'm just going to go over by 1. When x equals negative 1, the slope will be 1. Try to make something not too steep yet. These should all be the same. Okay, then when x equals 0, if I plug 0 in there, my slope will be 2. So it's gradually just going to get a little steeper. Then when x equals 1, my slope will be 1 plus 2 is 3. So now my slope is 3. And then when x equals 2, my slope will be 2 plus 2, which is 4. So now I'm going to try to get really steep. Okay, so that's what my slope field would look like. And if we wanted to go the other way, our next thing would be negative 1 going the other way. Righty, number 12. What is the formula for the arc length of the curve y equals f of x from x equals a to x equals b? So if we just want that formula, the length is going to equal the integral from a to b of the square root of 1 plus f prime of x, and then that will be squared dx. So that is the formula. Okay, number 13, the absolute maximum value of f of x equals x cubed plus x squared minus 8x plus 5 on the interval negative 4 to 2 is what? I know to find an absolute maximum value, I do need to find critical numbers first, so that's where I'm going to start. So my derivative is going to be 3x squared plus 2x minus 8. I would like to set that equal to 0. And I do notice this is going to be a magic number factoring problem once again. 3 times negative 8 is equal to negative 24. So what times what would give me negative 24? But add up to give me positive 2, and that would be negative 4 and positive 6. I'm going to divide out the 3 from the second part. So this will be 3x minus 4 and x plus 2. So my critical numbers are x equals 4/3 and x equals negative 2. And now to find an absolute, we're not going to draw an f prime chart. We're actually going to evaluate the function at my critical numbers and at my endpoint. So I'm going to evaluate it at 4/3. I'm going to evaluate it at negative 2. I'm also going to evaluate it at negative 4 and at 2 because those are my endpoints. So if I plug 4/3 into we're plugging these into the original function. So if I plug 4/3 into the original function, I get negative something, and I'm gonna, if I have to figure that out, I will figure it out in a minute, but we'll see if that's necessary. If I plug in negative 2, I get 17. If I plug in negative 4, I get negative 11. And if I plug in 2, I get 1. So since I wanted an absolute maximum, I really don't care. This turned out to be some sort of like negative 1 something, but I just want the absolute maximum. So the biggest value this function reached was 17. So my absolute maximum is 17. Okay, number 14, if dy dx is equal to 2x plus 1 times y plus 1, and x equals 1 when y equals 1, then y equals what? So if they're asking me to find, I have the derivative, I want y, which means I want to take an integral, but before we do that, we're going to cross multiply. So I'm going to get 1 dy is equal to 2x plus 1 times y plus 1 dx. We do need to separate our variables, so I'm going to divide both sides by y plus 1. So I'm going to get 1 dy over y plus 1 is equal to 2x plus 1 dx. Now that my variables are separated, I can take the integral of each side. The integral of the left side would be ln of y plus 1. the derivative of the right side, since there's a plus sign, we can actually take the integral of both parts separately. So this is going to be x squared plus x plus c. And then from here, I do want to do logarithm loop, and when I do that, I'm going to get y plus 1 is equal to c e to the x squared plus x. Remember, I love to bring that c out front. And then from here, I'm going to subtract 1, so I'll get y equals c e to the x squared plus x minus 1. And then from here, they did give me an initial condition, so that means I want to find c. So y equals 1 when we've got x equals negative 1, so c e to the negative 1 squared plus 1 minus 1, so I'm going to get 1 equals c e to the, x was negative 1, so that's going to be a negative there. So we're going to get 1 plus negative 1, which is going to give me 0. E to the 0 is 1. I'm going to add 1 to both sides, and that gives me that c is equal to 2. So my final answer is going to be y equals 2e to the x squared plus x minus 1. And voila.